everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a really cool logarithmic equation with complex numbers. How interesting this can get, right? We have everything. We have the trigonometry, we have tangent, I, ln, pi, jumbo mumbo. So how do you solve an equation like this? If you knew an identity, this would be super duper easy. But without the identity, how do you solve it? That's what we're going to talk about. Because with the identity, even though it's not cheating, it's kind of cheating, right? Don't you think? You have to come up with the identity or just memorize it. Memorizing is not always a good idea because you easily forget something that you memorize. But if you understand the process, of course, there are certain things you need to know by heart. But if you understand the general idea, hopefully you can always come up with the formula. Okay? Now, how do we solve a problem like this? Because of the ln, which is the natural log, we're going to go ahead and use the properties of logarithms, which is the base is e, right? So we can put a little e here to make our lives easier. And by using the properties of logarithms, you start at the base and you go across, ta-da-da-da, and that becomes the exponent, and this becomes the result. I usually teach it to my students like that. If you're talking about logarithms, you should always think about the definition because that helps solve a lot of problems. In this case, it's very helpful because you don't need to know any formulas. Now, where do we go from here? Well, we start with e to the power that. So e to the power I pi over 3 is equal to the expression inside the parentheses 1 plus I tangent theta divided by 1 minus I times tangent theta. Okay, you might be asking like, okay, fine, but what about this, right? There's a couple things we need to talk about. First of all, what is e to the power I something means? It's an exponential, but a complex exponential. And Euler, because he is the best mathematician of all times, right? He gave us a beautiful formula. And guess what that looks like? E to the power I theta equals cosine theta plus I sine theta. So you could go ahead and replace this theta with pi over 3 here. Do you see that? And then you will get a complex number in return. And then you can set the complex number equal to this and hopefully solve for something. What are we solving for though? I guess we're solving for theta because that's the only variable. I'm not talking about this theta. Maybe I should use another variable like alpha. But you get the idea, right? This is the most beautiful equation, or the most beautiful equation comes from here. Maybe one day we'll talk about it in more detail. But right now, what do you get out of this? Replace theta with pi over 3. You get e to the power I pi over 3. Again, this is theta. You should be able to isolate that. Cosine pi over 3 plus I sine pi over 3. What is pi over 3 in degrees? If pi represents 180 degrees, this should represent 60 degrees. So it's kind of like cosine 60 degrees. I usually don't write the degree symbol, but to avoid confusion, I'm going to write it here maybe once. So now cosine 60 degrees is sine 30 degrees, which is 1/2. And this is root 3 over 2 I. Some people write it as I times root 3 over 2, but I usually write it like that. So that it fits the pattern A plus BI, which is the name of this channel, by the way. Don't you ever forget that, okay? Make sure also to check out Cybermath, which is another channel that I have, which is my very first channel. Cybermath, cyber with an S. Check it out and let me know what you think. So now we have the left-hand side turned into a complex number. We can set it equal to this, and from there, we should be able to solve for tangent theta, right? Sure, you can do that. That's one way to approach it. So you can kind of put the 1 plus I tan theta here, divide by 1 minus I tan theta here, and try to solve for tangent theta from here. That's going to be interesting. So here's what I can do. I can set this equal to z for now, and just try to solve for tangent theta in terms of z, and then plug in z for what it is. What am I talking about? So cross multiply. This is probably easier, so you don't have to write the whole thing the whole time. Ci tangent theta. Now remember, our goal is to solve for tangent theta, so put this over here, bring it. And oops, that's supposed to be a plus sign. zi tan theta, and then bring the 1 over here with a minus sign, and then factor out tangent theta. You'll get I plus zi. Actually, you know what? There's a better way to do it. Factor out I tangent theta. You get 1 plus z and z minus 1. So from here, tangent theta. Now you can divide by I as well, or just multiply by negative. Actually, let me do that first because that makes things a little easier. Multiply by negative I, multiply by negative I. And then this becomes 1 because, oops, I forgot to say that. Sorry about it. I squared is negative 1 because I is the square root of negative 1. So negative I squared would be positive 1. You got that? Hopefully. Now, we got rid of that, and we end up with this. So let's go ahead and divide both sides by 1 plus z, negative I, times z minus 1, divided by 1 plus z. You see, this is why I wanted to name that z so that I didn't have to write the whole thing over and over. That would be super boring, don't you think? Time consuming. So, now you can replace z with that. Tangent theta is negative I multiplied by, what is z? Z is 1/2 plus root 3 over 2i. And then, of course, you have to subtract 1 from it. And then in the denominator, you have to add 1 plus z, which is 1/2 plus root 3 over 2i. That is interesting. What are we going to do from here? Well, we can combine these two things, and then negative I will stay. We can combine these two things. So tangent theta becomes negative I times negative 1/2 plus root 3 over 2i divided by 3/2 plus root 3 over 2i. What is going on here? How is that equal to tangent theta? And what is the formula for tangent theta? Those are all the things that we need to talk about. And if you go ahead and remember the formula, so here's what we have. Sine theta is e to the I theta minus e to the negative I theta divided by 2i. Cosine theta is e to the I theta plus e to the negative I theta divided by 2. Divide sine by cosine. 2's are going to cancel out. Set it equal to this. Solve for e to the I theta, so on and so forth. That's a lot of work, isn't it? Yeah, there must be an easier way to do it. And let's go ahead and talk about the second method, because I think the first method is going to take a while for us to do. Even though you can still attempt it, it is going to be a good exercise for you. So, again, the original problem, 1 plus I tangent theta, 1 minus I tangent theta. We ln that, and then it's equal to I pi over 3. And we said that, okay, this expression should equal e to the power, right? If you just put it on the left-hand side, now we should get e to the power I pi over 3. And Euler gave us something nice. But let's hold on to that for now. Don't expand it. Don't use Euler's formula yet. Let's simplify this first. How? Using definition of tangent. What is tangent theta? Sine theta over cosine theta. Beautiful. Do the same thing in the denominator. And then guess what? Multiply the numerator and the denominator by cosine theta, therefore getting something super duper nice. I mean, you're not going to believe this. It's amazing. Cosine theta plus I sine theta divided by cosine theta minus I sine theta. You see? Hidden beauty, right? Now, this is equal to that. Okay, fine. But what is that supposed to mean? Here's the thing. If you remember Euler's formula, this is e to the I theta. Beautiful. And what about this? Well, cosine is an even function, so it'll absorb the minus sign, like, okay? So cosine of negative theta is cosine of theta. But sine of negative theta will be negative sine theta, because sine is odd, weird function, right? So this becomes e to the power negative I theta. I hope that makes sense. By replacing theta with negative theta, we get the denominator. And by dividing these two things, they are exponential, so easy to divide. That gives us e to the power I times 2 theta, because you're supposed to subtract the exponents. I theta minus I theta is I theta plus I theta. To break it down kind of here, that is 2 I theta, but I write it as I times 2 theta. Why? Because we're about to ta-da-da-da. We're about to set these equal to each other, okay? Now, we get from here, because they both have I, natural logs, blah, blah, blah. We get 2 theta equals pi over 3. Guess what though? We are allowed to multiply both sides by e to the power I times 2 pi n. So that kind of gives us that addition, which can be helpful when n is an integer. I think I'm able to add it on the one side, right? That's what I got as a comment. So thank you, Descartes. Now we're going to divide by 2, and that'll give us hopefully all the solutions where n is an integer. What is that supposed to mean? If theta is pi over 6 or pi over 6 plus pi, which is 7 pi over 6, so on and so forth, it'll satisfy the original equation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out Cyber Math and aplusbi. And bye-bye.